A mass attached to a spring is set into simple harmonic motion in the horizontal direction. There are three parts to the problem. First, you want to find the maximum speed, then where this maximum speed is located, and finally the speed when the mass is at a distance halfway between equilibrium and the amplitude. First, let's list our given data. We have the mass, spring constant, and amplitude. In part A, we want to find the maximum velocity. Here is the formula to solve for it. We substitute in our values and find our maximum velocity to be 1.0 meters per second. In part B, we want to know where this maximum velocity occurs. It occurs at the equilibrium position. This is because at this position the amplitude is zero, making the potential energy zero. Our spring's total energy will be made completely from its kinetic energy, giving the mass its maximum velocity. Now in part C, we want to find the velocity at a specific point between equilibrium and the amplitude. We use this formula to solve for the velocity. Notice the velocity can be positive or negative. This is because as it moves back and forth in simple harmonic motion, the spring will be stretched past equilibrium, which yields negative velocity. And the spring will also be compressed behind equilibrium, giving the spring a positive velocity. We have to find the distance x before we can solve the problem. The point we are interested in is half amplitude position, or halfway between the equilibrium and maximum amplitude. We will find x by dividing the amplitude in half. Now we can solve the variables back into our equation, and we can find our velocity.